We are live. All right. Sorry, we'll need my glasses on. Okay. We're going to be talking about, up to this point, we've learned how to simplify radicals, right? And they're not that hard, right? They're pretty easy to do once you understand the process. They get a little harder if they're really big numbers. That's because you don't know your times table's really high, right? That's all, right? But if you did, they'd be really easy, right? And then we also know how to multiply, right? And we've learned with multiplying that, what did we learn? We learned that the square root of, let me think here. Yeah, we learned that the square root of, so 2 times the square root of 3 is the same as saying the square root of 2 times 3. So that's interesting. When you're multiplying separate radicals, you can put them under the same radical sign and have the numbers under just 1, right? That's interesting. So that's true with multiplying. It's also true with division. And how would you normally write a division problem? Like, what's the common way to write division? It's not even called division, it's called a fraction, right? A fraction is a division problem. Numerator divided by denominator, right? Numerator divided by denominator, right? Right? So if I said something like this, the square root of 12 over the square root of 3. Oh my God, that looks like a nightmare. Well, sort of. It doesn't look like a nightmare. I could make it look like a nightmare, but it doesn't look like a nightmare yet. But, what? Say it again?
So do you multiply them and then?
That'd be equal to the square.
But this is this divided by this, right?
Yeah.
Right, it's not multiply, now we're dividing, right? Because this,
Would that be equal to the square root of 4?
correct. So let's see. So because just like we did up here, we were able to put them under the same square root sign, right? And so let's do that. Let's put it under one big long square root sign, and we have 12 over 3. Suddenly this looks easier, right? The nightmare became just sort of a mild disturbance in the force, right? And then, why are you laughing? I feel like I have to crack another joke just to keep the whatever. Okay, so that is 12 divided by 3 is 4. Square root of 4, and that is 2. Does that make sense? It's really pretty easy, right? So nothing I did there was hard at all, right? Now, if you had chosen not to put it all under a square root sign, okay, thank you, Maya. Yep.
Jerry
Maya,
laughs
I just want you to breathe, okay?
Jerry laughs
At some
and he
point.
goes,
Why did you?
All right.
I'm literally crying.
Oh, you're crying.
Because I'm laughing so
Oh, you're laughing and crying.
much.
Okay, this is a great
Crying
video.
because she's
Okay.
laughing.
Okay.
Now, had I chosen to not do this, right? Let's see what would have happened, okay? I could have still solved this. If I did the square root of 12 over the square root of 3, I think this is easier, the way I did it there. But here's another way. I could say, how do I simplify the square root of 12?
6 times 2.
You're looking for perfect squares. 6 and 2 are not perfect squares.
4 times 3.
4 times 3. So I could say the square root of 4 times the square root of 3 all over a square root of 3. What's the square root of 3 over square root of 3 equal? 1, right? Well, yeah, if I multiply, it equals 3. But if I divide, if I have the same thing upstairs, just like 10 over 10, or 12 over 12, or 100 over 100, square root of 3 over square root of 3 is 1. So all I have left is the square root of 4, which is 2. Right? Either way, they're both pretty easy. But it's important to understand this thing, just so that you have that.
So there's 2 different ways you can do it?
Yeah, you can do it. You could choose to do it like this, or you could choose to do it like that. Okay, so let me just think where I want to go with this now. Let's say, okay, this was 1A, and 1B, right? All right, so now I think I can go over here. I still got some space. Okay, so let's try. How about we do the square root of I don't know, 18 over the square root of 6. Let's try that. Well, so help me do this. What would I do?
So that would be 1, so that would be equal to the square root of 3.
Right, so he's immediately doing this, I think. He's going 18 over 6, which is the square root of 18 divided by 6 is 3. So the answer is square root of 3, right? Is that how you did it in your brain?
Well, I just kind of like divide it and figure that it's going to be square root. I don't know. I don't really think of it like anything. I just kind of do it.
So you didn't use your brain. Okay, that's good. Good to know. So you don't need your brain for radicals, right? That's really helpful. Okay, so what if I did, trying to think of anything that would be weird. What if I did something like this? The square root, so that was number 2. Let's do number 3. Let's say the square root, let's see. Yeah, we'll just keep it simple first. Square root of 10 over the square root of 15. Huh. Well, I think it would be useful.
Square root of 0.5.
Personally, I think if it were me, I would try putting them under the same square root sign and just sort of see what I could do. Now, can I simplify 10 over 15?
Yeah.
Henry, how would I do it? Help me. 10 over 15. What goes in? Oh, no, I can't. Oh, yes, I can. What goes into both? Sorry. 5 goes into both. So I could divide this by 5. So 5 goes into 10 twice. 5 goes into 15 3 times. Okay? So technically, what I have is a fraction under a radical. And a fraction under a radical is not the way you want your final answer. So if I kept going, I'd have the square root of 2 over the square root of 3. You see what I did? All I did is I just separated them, right? Now, there is a rule in math that says, what?
I said it would be the square root.
Okay, so I guess that's a possibility. You could do that. But there is a rule in math that says do not leave a radical in the denominator. And I'll explain that in a little while, why they did that. And it's real, to be honest with you, a lot of it's because of the olden days when they didn't have calculators. I'll explain that in a little bit. But the square root of 2 over the square root of 3 is not an acceptable answer. Even though that is true, it's the right answer. It's just not acceptable in math standards, right? And so we have to do something to get rid of the square root of 3 out of the denominator. Okay? And what we're doing then to do that is called rationalizing the denominator. See that? Rationalizing the denominator. I'll explain why we're doing it in a second, but let me show you how you do it. Why is this not working?
Is it permanent?
There we go. No, fortunately not. I have done that before though. All right, so we're not quite done yet. We've got to do something rationally. Well, I guess I'll continue here. What could I multiply? What's the easiest thing that I could multiply the denominator by to get rid of the square root sign?
3. Or like, 3 over 1.
The square root of 3, right?
Yeah.
The square root of 3. Did you guys agree with him? If I multiplied this denominator by the square root of 3, I'd get rid of the square root sign, and then I just have a 3, right? Okay, but I don't want to change the value of this fraction. I just want to change the way it looks. I don't want to change this value. So the only way to not change the value is to multiply it times 1. but I want to multiply it times a weird one, right? You're going to hear that term a lot, weird ones, a really weird one. So how could I do it? You just told me we're going to multiply the denominator times the square root of 3. What are we going to multiply the numerator by? Square root of 3. Then we're multiplying times the value of 1. So we're not changing its value, we're just changing the way it looks, right? So suddenly, I have, what would I have in the top, in the numerator?
Would it be like a big
Square root of
and then
2
2 times 3?
Wait, say it again?
Would it be like a big square root sign and then in it 2 times 3?
Yeah, and then I'm going to just do that in my head. 2 times 3 is 6, so I'm going to say the square root of 6. Does that work? You see what I mean?
So then
Downstairs, I have 3. Now that is an acceptable answer. Even though that was a true answer, it is not an acceptable answer. And even though that is a true answer, that is not an acceptable answer. You have to, because this shows, technically this is a square root sign in the denominator, right? And you can't leave it like that.
So wait, so wouldn't you do like 2? No.
No, I can't, because notice, remember, as with multiplying, I can't if something is not under a square root sign, I can't multiply it times something that is under a square root sign, right? Same thing is true with division. If am I still on this thing? Yeah, oh, phew, just barely. Okay, so I can't divide 3 into 6 because 3 is not in a square root, right? If 3 was in a square root sign, then I could.
They're completely different numbers.
They're completely different numbers, right? They're not the same. Because this is 3, this is not 6, this is the square root of 6, which is 2 point something 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 something, right? Times itself, right? So it's whatever. Now the question is why? Why rationalize, right? And it helps to just understand this, you know. I mean, it's not that important, but it just helps to understand it. Like if I had, let me just think of an example. Let's do something really simple. Let's say we had 1 over the square root of 5, okay? And I asked you to simplify that. Simplifying would mean I have to rationalize it because I can't leave the square root of 5 in the denominator, right? So what would I do? Help me.
5 over square root of 5.
Right, I would multiply this times that weird 1, which is the square root of 5 over the square root of 5. That would get rid of my square root signs here. So I'd have the square root of 5 over 5. You with me? Everybody sees that, right? Okay.
That would be correct.
Yeah, and technically they're both true. They're both correct, right? But that's the one that's official, right? Because we don't want to have like so many different ways that you could write the answer that we can't figure out, you know, which one's right. I mean, you'd have to figure out, okay, there's 5 different ways to write this answer. Oh my God, I got to figure this out 5 different ways and get 5 different answers, right? That's not helpful. So we're trying to standardize the answers. This particular type of a problem could show up in different ways. And so it's better to have a standard tool or a standard way to put the answer. So that helps. But then the other is back in the days when we didn't have calculators. Actually, my day, when I was a kid, right? We didn't have calculators. We had, at the back of our math book, every math textbook, just
I
so
know
you
you
know.
had that little thing.
We
You
had
had,
pages of charts, right? Pages of charts that would tell you what is the square root of 2. Well, square root of 1, square root of 2, square root of 3, square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, and it went on and on and on and
Wait,
on and
all
on.
the way to 11? No, wait, but 11.
Oh, it went through. It went.
No, but isn't the square root of 11 like super like long, like complicated?
Well, they would give you approximates. You know what I mean? Because a lot of them go on forever, right?
Yeah.
Square root of 2 goes on forever. Square root of 3, square root of 11. They all go on forever, many of them. And so, but you know, so they would just approximate, and they usually do it to the third, you know, point at third place, like the thousandth. So you'd have like 2.379, right, or whatever, right? And does anybody have a calculator on them? Or I guess I have.
I like that. I do.
So, well here, somebody type in, I don't know how it works on this one, but type in square root of 5.
Okay.
What do you get?
5.
Okay, type in square root.
Okay.
Okay, type in 5 square root. What'd you get?
2.2360679.
Wait, okay, so the square root of 5 you said was what?
2.2360679.
Right, and it goes on forever, right? It's going to go on forever, right? And now let's just think about it for a second. If we use this, if that was our answer back when I was growing up before calculators, right? I would have to do this. 1 divided by this. So I'd have to do 1 divided by 2.2360679. Do you see how like a nightmare that would be? Like how many times does 2.2360679 go into 1? Right? I don't know. Right? I would, you know, it doesn't go into 1. So I'd have to put a decimal here. Okay, how many times does that go into a 10? That would be a nightmare. And then I have to multiply forever, right? It would take forever. Now, however, let's look at this one. This would be much easier because it's really 5 divided into 2.2360679, right? What?
Kick the camera.
On accident.
Eric!
Carrie, is that a dry
I think
erase?
we're okay. What?
That's a dry erase marker?
Believe it or not, yes,
Wow.
it says that. It's
Oh,
awesome.
that is a smelly marker.
Yeah, but it works. It works great.
Sorry, I didn't even interrupt.
Dry erase marker.
All right, here we go.
Wait, is that what's been smelling?
But now, look, you guys, this would be so much easier to divide by, right? When you're dividing by a number, a simple number, it's so much easier. It'd be so easy. 5 goes into 22. If I bring up my decimal, 5 goes to 22 4 times. 4 times 5 is 20, right? See how quick and easy this is? It's easy. So back in my day, it was easier to divide by a non-radical than to divide by a radical. So it was better to write it like this. So that's how it started, right? Nowadays, though, with a calculator, it doesn't really make a diddly squat of difference which way you do it, because all you do is just type it in your calculator and it gives you poof an answer, right? So, but still, we have this formal reason, right? That's the formal reason. That's why it got started that way. So now let's look at some harder problems. What time is it? Oh, I should probably go look at these. Okay, so all right, so now let's just do a few problems that are harder. I don't know. I think we're okay. Do you guys feel like you get it?
Yes.
So shall I just give you the homework right now, and then you can work on, and then you can ask. Let's end this thing.